Welcome dear students to Computer Studies Standard 9th English Medium, Chapter number 4, Part 4. Today we are going to discuss the last topic of this chapter, and that is data representation into computer memory. The topics which we are going to discuss in this video are data representation into computer memory, binary number system. You all know what is binary number system, am I right? In primary you may have studied about it. Then a thing which will be taught to you in this video will be conversion of a decimal number into binary number and conversion of a binary number into a decimal number. It will be like performing the sums of mathematics. Thereafter, unsigned integer number representation. Then signed integer number representation. Now what is signed or unsigned integer? Unsigned means a number which is not having plus or minus sign in before that number is a unsigned number. We can say alphabet is a unsigned number, while signed means what? That -5, -10, that means signed integer. Now to convert a signed integer into a binary number, there are three different methods. The first one is sign magnitude method. Another method to convert is first component method, and the third one is second component method. Now we all are familiar with the decimal numbers, am I right? The number system which we are using in our daily life is known as decimal number system. Now decimal number system is a positional number system, that is zeros, tens, hundreds, like that way. So it depends on the position of the number. For example, 916, then 9 means 900. 1 means 10 and 6 means 6. That is, it depends on the position of the number that how much is its weightage. Now, here we have got 10 symbols which are called digits. That is 0 to 9. Am I right? Fine. Now, in the language which we speak or how we communicate with each other, we have got decimals. Then we have got alphabets, right? Besides number, we use the alphabets from capital A to Z and small a to Z in written form also. Then mixture of both, that is alphabets and number, is known as alphanumeric. This also could be asked in the MCQ. Now in this video, I have not marked all the MCQs using red color. Why? Because there were children who were not ready to understand whatever I am teaching. They were just interested in finding out the MCQs from the video. So little bit I have to change. Now besides alphanumeric, we have got special characters. Now what are special characters? That is punctuation marks, operators such as plus, minus, multiplication, division, etc. and many more. All the characters which are not there on the keyboard and we can insert them, those are also known as special characters. Now, for a proper communication, we need to arrange all these digits, characters and symbols in some meaningful way using the laws of grammar. Am I right? We cannot arrange anything anyhow and the meaningful sentence will be made. We have to keep in mind the grammar and all the things of each language. Now, besides this thing, language, that is spoken or written language, another type of language is sign language. Now, for specially abled people, that is the people who are deaf, who cannot listen to us, we can communicate with them using the sign language. Here you can, in the picture you can see, by making different signs using our hand, different alphabets could be represented. Then another thing, that braille languages are used for differently abled people, right? Then body language is there, or with the help of facial expressions also you can express anything. A smile can say 100, more than 100 words, right? Fine. Now, when we talk about computer cannot understand any of the language which we discussed just now. Computer, being an electronic device, is not comfortable from the above mentioned any of the languages. It works on electricity, which has only two states, that is on and off. Hence, it requires a special bi-state language having only two symbols, one to represent off and another to represent on. So computer stores everything in the form of 0 and 1, that is binary form. Below is given a coding of an image. Now you cannot see any image there, right? You can see only 0, 1, 0, 1. But that is, the image is stored in the binary form in the zeros and ones. So now we will discuss the binary number system. Now the binary number system, as discussed earlier, has got two symbols, that is 0 and 1. A single binary digit is called a bit. 8 bit forms 1 byte. Now a valid binary number example is 101, right? Just now we saw that it can store 0 and 1. So in this 101 we have got 1 and 0 only. So it is a valid number. But since the binary number uses only two symbols, while 102 is not a correct binary number. However, it is a correct decimal, but 2 does not exist in a binary number system. Now, to identify a binary number, suffix B, capital B, small b or 2 is used. For example, if 101 is written, then you can also consider it as 101, and you can also consider it as a binary number, right? But how will you be able to justify whether it is a binary number or is it a decimal number? So a suffix is used. Here you can see small b is written as subscript, right? Or you can also write capital B, small b, or since the base of binary number is 2, so even 2 can be written as a suffix. While in decimal number system, you can write in suffix as a capital D or small d or 10. Why 10? Because the base of decimal number system is 10. From 0 to 9, if you count the number of digits, it is 10. Now, this number means, here I have given a number 101. Now in decimal number system, it means 101 because 100 plus 00 plus 1. While in the binary number system, 101 as a meaning, it is 5. I will now teach you the thing how to convert a binary number into decimal number and decimal number into binary. That I will have to use the blackboard now. Now, here I will be teaching you both the things, how to convert a decimal number into binary and binary number into decimal. The one thing which is sure and certain is, in the exams, in the MCQ part, 110%, 1 or 2 questions will be asked from this part. Fine. So, first we learn the conversion of binary into decimal. So, here we take an example. 101. If this is the binary number given to you, then in the question it will be asked like this way. 2. If this 2 is not kept here and if it is kept 10, then it means that it is 101 and it is a decimal number. But since 2 is put in the prefix, suffix, it means that it is a binary number. Now how shall we find the answer? It's very simple. First thing is, the question will be asked like this way. Okay? So first thing is, I will write this number separately. 1, 0 and 1. Okay? First step. Next step. Since the base of binary is 2, I will multiply each and every digit with 2. Now, what is the weightage of 2 here? The weightage of 2 here is 2 raised to 0. While the weightage of 2 here is 2 raised to 1. And the weightage of 2 here is 2 raised to 2. Next thing is, I have to put the brackets here. And I have to put a addition sign in between. Remember this thing? Now, 1 into 2 raised to 2 is 4. Now, plus 0 into 2 raised to 1 is 2. Plus 1 into anything raised to 0 is 1. So, 1 into 1. So, 4 plus 0 plus 1. So, the answer here is 5. So, this is the method how to convert a binary number into decimal. Now, I will solve one more example to clarify the thing. One, 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 0, 1, 1, 0, 1. Now in exams, this simple example which we solved just now, that is 1, 0, 1, may not be asked. This much long number will be asked to you in the MCQ. So we will try to solve this thing. Fine. The technique remains the same. 1, 1, 1, 0, 1, 1, 0 and 1. So like this way, first you have to add this thing into 2. Then you have to start from here. 0, 1, 2, 3, 4, 5, 6 and 7. Then add brackets. Then add plus sign between. Now, never start the solving of the thing from the left hand side, always start from the right hand side. That will be easy for you. So, I start from the right hand side. 1 into 1 plus 0 into 2 plus 1 into 4. Always remember that you have to start from that side to avoid any of the mistake. Now I start from this side. 128 plus 64 plus 32 plus 0 plus 8 plus 4 plus 0 and plus 1. So by adding all this number, whatever answer you get, that will be the decimal form of 111011101. So now we are going to learn how to convert a given decimal number into its binary form. Now see, in reality, whatever number we enter in the computer, or whatever alphabets, whatever things we enter in the computer is stored in the form of zeros and ones, right? We know that fact. Now here in this chapter you are not asked to learn how to convert an image into binary, or how to convert a character into binary. But in this chapter you are taught simple things. For example, converting a number into decimal number into binary. So let's begin. For example, the number which is given here is 125. Now to denote that this is a decimal number, okay, a suffix 10 is used. So this answer we have to find. How shall we do this thing? So to write here 125. What is the base of binary number system? The base of binary number system is 2. So you have to divide this number by 2, and you have to go on dividing this number by 2. Okay, 2 into 62. Okay, when you multiply 2 into 62, the answer is 124. So remainder is 1. That you have to write here. 231. If you multiply 2 by 31, answer is 62. So remainder is 0. 2, 15 is 30. Remainder is 1. 2, 7 are 14. So remainder is 1. 2, 3 are 6. Remainder is 1. 2 1s are 2. Remainder is 1. So now, how to find the answer, whether 101111 or 1111 into 10? So you have to consider it like this way. This will come first, this will come last. So here the answer is 1, 1, 1, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 0 and 1. So this is the simple method how to find the thing. Okay. Now we will solve one more easy example. Okay. Just now we had learned how to convert a binary number which was 101 into decimal, and the answer we were getting was 5. Now we will try to convert 5 into binary, and we will check whether it is 101 or not. This is called cross checking. Okay, so I will type here 5. Two twos are 4. Remainder is 1. 2 ones are 2. Remainder is 0. So the answer is 1, 0, 1. Very simple, isn't it? So we also successfully cross-check the thing that 1, 0, 1 is equal to 5 and 5 is equal to 1, 0, 1. So this is how the numbers are converted. Now one more thing which is very important for you all to know, okay, that I am explaining you here, which will be helpful to you lifetime and whenever you are preparing for any external exams, okay, in future maybe say GPSC or GATE exams, that time also this knowledge will be useful to you, so that thing I am teaching you just now. Now here I am writing the decimal numbers. Here I am writing the binary numbers. Okay, decimal of number 0, 1, 2, 3, 4, 5, 6 and so on. Okay. Now in decimal we have got up to 10 digits, 0 to 9. Okay. So when we reach 9 here, which will be the next possible number, there is no number bigger than 9. So 9 will be converted into the smallest number. Which is the smallest number here? 0. And then the series will start from here 1. Okay, now this will go on till 19. Okay, 1 will remain same and here the numbers will change. Then when there is no bigger number than 9, it will turn into 0 and then it will change this number 20 and so on. Now in binary number, how is the system working? The binary of 0 is 0. Binary of 1 is 1. Now here we have got only two numbers, 0 and 1. So what is the number bigger than 1? There is no number bigger than 1, so it will turn 0 and then here it will end 1. Now again it will start from this side. The bigger number than 0 is 1. This 1 will remain as it is. So binary number of 3 is 1, 1. Then 4. Now this 1 will turn into 0. This will turn into 0 and here it was 0 by default, so it will be added 1. Now again 1, 0 will remain as it is and last digit will change. So 5 is 1, 0, 1. Then 6 will be 1, 1, 0. 7 will be 1, 1, 1. Okay. Then 8 will be 0, 0, 0 and 1 and so on. So like this way is the number system of binary. So we complete this topic over here. I wanted to teach you the methods, that is sign magnitude method and complement method, but this video is getting too long, so that I will be teaching you in the next video. This video will complete over here.